So today's project that I'm going to be presenting is on butanol and its importance for the plastics, polymers, and food. To learn more about its importance on these three things, you can go to ecolink.com. They did an article in 2019 which expands on how butanol is very important for the production of these three. From an article done by Conservative Energy Future, it was found that there are 6 different types of biofuel and 6 different crops to produce those biofuels. The 6 different types of biofuel are wood, biogas, biodiesel, ethanol, methanol, and butanol. And the 6 different crops which are used to produce those biofuels are corn, rapeseed/canola, sugarcane, palm oil, jatropha, and soybean. Butanol is produced by the fermentation of corn. And this mass balance was pulled from an article done in 2015 by Science Direct, and it shows how corn straw is put into the reaction in the beginning, which this corn straw then goes to a chamber where you have a steam explosion, and the product stream from here goes to a hydrolysis chamber, which is mixed with sulfuric acid. And the purpose of this is to separate your 2 product streams into a distillate that's mainly liquid, and then a residual distillate that has particles in it. And so these particles then go and are mixed with xylose, which is a sugar that is pulled from wood that will assist in the fermentation that happens later in the process. And then here you have corn juice being put into the process, which is then fermented by the Clostridia species. And there's 4 different types of bacteria from the Clostridia species that are acting to ferment this solution that's going in. And then here on the right, we can see that there are 5 different product streams coming out of this reaction. You have the production of butanol, acetone, ethanol, hydrogen, and carbon dioxide. Now, it's important to note that the production process for ethanol and butanol is very similar, as you can see, but ethanol is always the more preferred biofuel to use because of its cost effectiveness. Butanol is a lot harder to produce. The percent yield is not nearly as high. So most scientists within this community of biofuels will recommend ethanol. But one thing that butanol does have going for it, according to the EPA website, corn grain butanol meets the renewable 20% greenhouse gas emission reduction threshold, which means that the CO2 emissions that are given off by burning butanol can easily be offset by the regrowth of corn crops. And the CO2 emission is essentially canceled out by that growth of crops and its emissions. I will say that butanol is still in its research and development phase because of its high costs, and funding should definitely be put into researching more effective bacteria used for fermentation, and also research put into which sugar could assist in fermentation, because if this fermentation process becomes more efficient, you get more product stream, which means that the percent yield is higher and the cost of producing butanol becomes lower, and it's a lot easier for scientists to recommend. As far as the communication of butanol is used to the public, butanol is definitely a biofuel that a lot of people have heard about. It's just not one that you typically see being sold or used in a lot of processes. You do see them a little bit in plastics, in the production of plastics polymers in certain food industries, but the biofuel that is preferred because of its similar effects and the way it's used would definitely be ethanol. Butanol is definitely one of those biofuels that is not used as much. But yeah, that's my project on butanol.